All right, we are going to go to the next lesson in this chapter, which is the inverse trigonometric functions. And I do want to clarify that when I say sine to the -1x, that is not the same thing as 1 over sine x. There's a different context here where the -1, even though it looks like an exponent, it is the inverse function. Normally sine x would take an angle and it would give you the ratio of the two sides, opposite and hypotenuse. What sine inverse does is it takes those two, or the ratio of those two sides, opposite and hypotenuse, and it tells you what angle would give you that ratio. So it's an inverse function, not 1 over sine or 1 over cos. It is an inverse function. So let's be clear on that, and then we will move on. So to do this, we need to, first of all, since I have nowhere to go from this, I can't start at first principles. This is not a complex version of a much simpler function, so I have to use a different approach. And here's the approach I'm going to use. Instead of saying that y is the inverse sine of x, I'm going to, if I literally take the sine of both sides, then the right or the left side becomes sine y, and the left side becomes the sine of the inverse sine of x, which is just x. So my new function is x equals the sine of y. And then from here, I'm going to do implicit differentiation, which we have done before, taking the derivative of everything with respect to x. So the derivative of x is just 1. The derivative of sine y, I have to use chain rule again. First take the derivative of the sine part, and the derivative of sine is cosine of y. But then I've also got to take the derivative of y and multiply by that after. And since I don't know, well, I do know what y is, it's the inverse sine of x, but I'm just going to call it dy dx, because the derivative of y is always dy over dx, regardless of what the function y is. So now I'm going to solve for dy dx. And to do that, I just need to divide out that cosine of y. All right. So here's where things get tricky, because I want my derivative to be in terms of x, not in terms of y. So let's go back up here. Let me just erase these little circles here, because those are going to get in my way. And let's just talk about what this sentence means here. X equals the sine of y. Well, y would have to be an angle since I'm taking the sine of it. So let me put my y down here. And then the sine of it would be the opposite over the hypotenuse. So x is like x over 1. So I'm basically creating a ratio of this angle where the opposite is x and the hypotenuse is 1. So here's my opposite, which I will call x, and here's my hypotenuse, which I will call 1. All right, and now I can go back down to the bottom and I can say, well, the derivative of that is 1 over cosine y. So I need the cosine of this angle instead of the sine of this angle, which means I need the adjacent and the hypotenuse. Well, I have the hypotenuse, it's still 1. What I don't have is this adjacent side right here. So what I need to do is just a little bit of Pythagorean theorem, because this is a right triangle, and say that this side, if you figured it all out using the Pythagorean theorem, you would get that this is equal to the square root of 1 squared minus x squared. So that's what this side is, regardless of what the measurement of x is. So the cosine of y would then be root 1 minus x squared over 1. And I can ignore the over 1 part. So the cosine of y would simply be the square root of 1 minus x squared. So I'm just going to make that replacement. Okay, so this is the derivative of inverse sine of x. Again, that's something you can write on a note card or a flash card or whatever and use those to study. Again, it is on your formula chart, but remember, you want to memorize as much as possible so that you don't have to keep flipping back and forth. All right, I'm going to use the same process for inverse cosine. Okay, rewrite it as x equals the cosine of y. Take the derivative of x is 1, the derivative of cosine is negative sine. Chain rule says then I've got to multiply by the derivative of y, which is dy dx. All right. So if I'm solving for dy dx, I'm going to divide out the negative, I'm going to divide out the sine y. So again, I've got to put my angle y here, And this time the cosine of y is x over 1. So that means that now the adjacent is x and the hypotenuse is 1. And by the same logic, now this side becomes the square root of 1 minus x squared by Pythagorean theorem. Okay. Alright, so in order to express this derivative in terms of x instead of y, I've got to write sine y as something in terms of x. So the sine of y is going to be the opposite over the hypotenuse, which is root 1 minus x squared over 1. I can ignore the over 1 part, so the sine of y is just the square root of 1 minus x squared. So this actually looks a lot like the last one I did. The only difference is there's a negative 1 on top instead of a positive 1 on top. So that's a trick to help you remember both of those. Alright. And then lastly, we will do inverse tangent. Okay. Same process. X is going to equal the tangent of y. Remember, the derivative of tangent is secant squared. So the derivative of x is 1. The derivative of tangent is secant squared. Chain rule says I've got to multiply by the derivative of y, which is dy dx. So let's look at what I've got here. I'm dividing by secant squared so that I can get dy dx by itself. And we know that 1 over secant squared is cosine squared. Okay, so that's the derivative. But again, I've got the same problem. I've got this y here. So let's look at what's going on again. Here's my angle that measures y. The tangent of it is going to be x over 1, so that means the opposite will be x. And now the adjacent will be 1. Alright, so we can assume this is a right triangle. Pythagorean theorem will say that this hypotenuse has a length of 1 square root of 1 plus x squared. Alright, so what does that mean? That means that the derivative is the cosine of this angle, which is the adjacent over the hypotenuse, but all of that is being squared. So what that is this fraction here, 1 over the square root of 1 plus x squared, and all of that is cosine of y, but all of that is being squared, which is going to take care of the square root on the bottom. Oh, I actually typed that in. So it's all of that squared, which makes the 1 a 1, and it makes the square root of 1 plus x squared just 1 plus x squared. So the derivative of inverse tangent is 1 over 1 plus x squared. Okay, again, all of those can go on flashcards, note cards, and everything that I've said before about how to use those. So let's talk about an example where I'm using the chain rule. So if I'm finding the derivative of inverse sine of 3x to the 4th, what I'm going to do is, I already know my rules, so what I'm going to do is, the first thing I'm going to do is take the derivative of the sine inverse part of that, which, as you remember, is 1 over the square root of 1 minus x squared, or whatever the argument is, squared. So that's going to look like this. It's going to be 1 over the square root of 1 minus that argument squared. And then chain rule says I've got to multiply by the derivative of that 3x to the 4th, which is 12x to the 3rd. So the only way to really make that look nice is to put the 12x to the 3rd on top and maybe square this 3x to the 4th, making it 9x to the 8th. Alright, and that again is an example using chain rule. We will go over examples using product rule, quotient rule, and we'll go over some applications of that tomorrow. So again, email me, Facebook me if you have questions, and I will see you tomorrow.